Hi, my name is Walter, and in this short video, I want to show how the Schmidt algorithm can be seen as a rotation. The Schmidt algorithm takes as input a set of vectors and returns as output two matrices. One of these matrices is called R, and I mainly want to show how R can be seen as a rotation of the input matrix. So these are the original input vectors. So R is going to be a version of these vectors that is rotated such that the green line is horizontal, but the angle between the lines is preserved. So I'm going to rotate these two vectors now to produce R. So you see the green line is horizontal, but the angle between the two lines is still preserved. The first column of the R matrix is the coordinates of the rotated green line. The second column of the R matrix are the coordinates of the rotated blue line. So in this video, I'm basically going to show how the values of the R matrix are calculated. In particular, I'm going to show how the x value of the I'm going to show how the x value of the rotated green line is calculated. The y value of the rotated green line is calculated. The x value of the rotated blue line is calculated, and how the y value of the rotated blue line is calculated. So how are the coordinates of the rotated green line calculated? So we can actually use the Pythagorean theorem to calculate the length of the green line before the rotation. So now I'm going to rotate it. So we see that the length of the green line is radical 2. Now I'm going to rotate it. So after the rotation, the coordinates of the green line are going to be radical 2, 0. That's going to be the first column of the R matrix. So let's move on now to the calculation of the coordinates of the rotated blue line. So first we can make a triangle by projecting the blue line onto the green line. The base of that triangle is going to be the x-coordinate of the rotated blue line. So in order to create that triangle, we have to project the blue line onto the green line. So on the right hand side, I show the calculations to produce that projection. So the projection is the vector 3, 3. So to get the base of that triangle, we can calculate the length of this vector 3, 3 by using the Pythagorean theorem again. So we see that the base of the triangle is 3 radical 2. And once we rotate it, we're going to see the x-coordinate of the rotated blue vector is also 3 radical 2. And I'm going to rotate it now. So you can see the x-coordinate is 3 radical 2 for the rotated blue line. So we move on to the y-coordinate of the rotated blue line. That's just going to be the height of that triangle we just created. So in order to find the height of that triangle, first we want to scoot that height of the triangle to the origin to create a height vector. Next, we want to scoot the base of that triangle we created before up to create a base vector. So now we can see that the height vector plus the base vector is going to create our original vector. And we can also see how the original subtract the base vector will give us the unknown height vector. And that is the unknown height vector is negative 1 and 1. And we do the same thing where we use the Pythagorean theorem to calculate the length again. So we can see the length is radical 2. So I'm going to rotate this, and we're going to see that the y value of that rotated blue line is going to be radical 2. And that's the second column of the R matrix.